Hi, we continue discuss chapter 23, lenses. Here's an important table. Let's give a quick review. P, the object distance, is be positive if on front of lens or on the left. So P is the negative, take negative sign if the back of the lens or right side. Now Q, image distance, is positive if the image is back of the lens or right side. I'll give you real image. Now the Q is negative if image in front of the lens. I'll give you virtual image. That's very important. If Q is positive, give you a real image. If it's negative, give you virtual image. Now the H prime, that's the height of image. So if image is upright, we take positive. If the image is inverted, upside down, then we take negative sign. And also this is very, very important. F, the focal length, when you calculate converging lens, F should be always positive. And for diverging lens or concave lens, always negative. Converging lens, F positive. Diverging lens, F negative. Okay, now let's quick review of this example. So we have a lens F, the focal length given 10 centimeter. So now we're going to calculate the image, different image formed when we have object on different direction. First, we set object 30 centimeter on the left front. So it's positive. So use this length equation 1 over F equals 1 over P plus 1 over Q. So F equals 10 and P equals 30. So then we can solve. We discussed how we did that last time, remember? Okay, we find Q, the image distance equals 15 centimeter. So it's positive. Positive. So it's real. So now we calculate magnification equals negative sign Q over P give you negative 0.5. So now we have the image which is real because P is positive. Inverted because the M is negative. Reduced because M smaller than 1. So this is the principle of camera. Now, second example, we discussed when P equals 15 centimeter. And then we calculate Q, the image distance equals 30 centimeter. And magnification equals, again, negative Q over P equals negative 30. That's Q over 15. That's P. Give you negative 2. So give you bigger image. So this image is real because Q is positive, is inverted because M is negative, but enlarged because M is bigger. The absolute value is bigger than 1. So the image is real, inverted, and enlarged. That's principle of a projector. Now let's see this one. If P equals 10 centimeter, the P equals F. So 1 over 10 equals 1 over 10, and we solve for Q. Now only solution, 1, because you see it here, 1 over Q equals 1 over 10 minus 1 over 10 give you 0. So the Q only solution is infinity, right? Because 1 over Q equals 0. So Q must equals infinity. 1 divided by infinity gives 0. So magnification, since Q equals infinity, magnification also equals infinity. this image is going to be at infinity, right? Because the object, sorry, image distance equal infinity. And you can also say there's no form, no image form. So no image. The image distance at infinity. So now the last one. Okay, what if P equals 5 centimeter? We want to find the Q and M. So we do same thing again. 1 over Q equals 1 over F equals 10 centimeter minus 1 over 5. So now if we use a calculator, 1 over 10 minus 1 over 5 give you negative 0.1. Negative 0.1. So now, okay, so Q equals 10 centimeter, but it's negative. Magnification equals negative Q over P. The Q equals negative 10 divided by 5, that's P, give you positive 2. See, what image is this one? The image is going to be virtual. Why? Because the image on left side, is negative, so it's virtual. Upright, because M is positive, and enlarged because bigger than 1. So this principle of well, magnifier. Now we can discuss diverging lens. Okay, so assume we have a diverging lens and F equals 10 centimeter. So that's magnitude equals 10. And you know when you solve problem for diverging, F should be always negative 10. Okay, so now here's the diverging lens, like that. The middle part is smaller size, edge is bigger. And again, we always choose the object on the left side, front, so always positive. Okay, we're going to discuss a different example. Part A, assume the object equals 30 centimeter, 30 centimeter, front of diverging lens. Okay, so we're going to use the lens equation. So now see we'll add a negative sign right here. 1 over 10. Okay, because the focal length equals 10 centimeter. Equals 1 over P equals 30. And we're going to solve for Q. Then we could do the same thing. 1 over Q equals 1 over 10 minus 1 over 30. So if you do this, see what we got. Use a calculator. Okay, that we got negative 0.133. I'll keep 3 number here. That's 1 over Q. So then Q equals 1 over this number. Okay, finally got negative 7.5 centimeter. It's negative. So now magnification equals negative Q over P, and Q equals negative 7.5. So I have negative, negative, that cancels. Divided by the object distance, 30 centimeter for this one. So you should have 7.5 over 30 give you 0.25, 1/4. So now this image is virtual. Why? Because Q is negative. Okay, it's upright because the M is positive, and reduced because it's smaller than 1. So it's only quarter of the size. So application 1 of applications like near sign glasses. Okay, now let's see second example. Okay, second example, we have p equals 10 centimeter, the object distance, and we want to find q and m. So 1 over 10 again, we need to have a negative sign because it's diverging length. Remember, f going to be negative, equals 1 over 10, that's p, and plus 1 over q. Okay, now if we solve it, 1 over q equals negative 1 over 10 minus negative 1 over 10. That's like a 0.1 plus 0.1, but both negative. I'll give you negative 0.2. So that's 1 over q. So then 1 over negative 0.2 give you 5 centimeter negative. So again, the virtue. So now magnification equals negative 5 over 10 give you 0.5. So again, the image is virtual because q is negative, and upright because m is positive, and reduced because smaller than 1. Now, third example you can practice. You will find, so here, third example, we have, this would be C, sorry. Okay, we should have the P equals 5 centimeter. We want to find Q and M. We plug in the number and we solve for Q. Then you find Q equals negative 3.33 centimeter. Magnification equals negative Q over P, negative 3.33 over 5 centimeter. That's P, and give you positive 0.67. Again, this image is virtual because Q is negative, upright because M is positive, and reduced because this number is smaller than 1. Okay, so remember here we have a conclusion. The diverging lengths always give you this kind of image. Always virtual, always upright, and always reduced. Not like the converging length. Converging length can give you real or virtual, enlarged or reduced, different image. But the diverging length always give you virtual, upright, and reduced. Another application is the for the flashlight, and use this like a magnifier and make the parallel light beam spread out to bigger angle. Also like the your car light at night will go a bigger angle, diverging. Now next we're going to study combination of thin lenses. We have 2 or more lenses in say series setup like this one. Well, it can be 2 converging lens and can be 1 converging, 1 diverging for different application we can discuss. So now it seems like a little complicated. It is not too much complicated. Okay, here's the rule. Now the image of the first lens is treated as the object of second lens. Okay, like this one. So you work 1 lens each time. So work first one. Okay, so you have start 3 beam. Okay, like we discussed before. Then focus at this point, give you the first image. So we call I1. That's the first image formed by first lens. So now this one be treated as the object of the second one. So now see, this is the object for the second lens. So this distance is going to be the object distance of second lens. Okay, so you also have to find it. You have to find it. For example, this one, the first image, the distance equals 15 centimeter. Okay, if you know the distance between the two lenses is 20, so how we can find the object second one? Should be 20 subtract 15, right? So then that will give you the object distance for second one. Okay, so now the image formed by second lens is the final image for the whole optical system. So work one each time, find the image first one, then that treat as object of second one, then you find the image of second one, which is final image for the system. Okay, in our textbook, we have an example, two lenses, both are converging lenses. The first one, focal length equal 10 centimeter, second one equal 20, and object, this will be P1. Okay, so we can call P because for the whole system. So this is the 30 centimeter from the first one, from first lens, this object. Object 30 centimeter to the first lens. And we want to find the final image. What's the final image distance? What's the magnification? We're going to study that. Okay. So now, we work first lens. P1 equals 30 centimeter. And we want to find Q1 and M1. I'll use length equation. 1 over F1 equals 1 over P1 plus 1 over Q1. Okay, since F1 equals 10 centimeters, so I have 1 over 10 equals 1 over 30. That's 30 plus 1 over Q1. We did this before. We know how to solve it. And if you solve, give you Q1 equals 15 centimeters. So make copy here again. So find this equals from the lens, first lens to the first image, 15 centimeter. Then we can find magnification. M1 equals negative Q15 over P30, give you negative 0.5. So the first image going to be real because Q1 is positive, reduced and inverted. Okay, so that's the first image. Now the first image is going to treat as the object of second one. So now we need to find this distance. So now the distance between the two lenses is 20 centimeters given. Given. So now 20 minus 15 will give you that distance, which is the P2 object distance of second lens. Okay, so P2 equals 20 minus 15 give you 5 centimeters. So now we're going to find the second image distance and magnification. We use same equation again. So now 1 over 20 because given F2 focal length, the second one equals 20 centimeters equals 1 over 5. You find from there P2 equals 5 plus 1 over Q2. So now if you solve this, you find Q2 equals negative 6.67 centimeter. Magnification of second one, M2 equals negative Q over P. The Q equals negative 6.67 and the P equals 5 centimeter. and this give you, because negative sign canceled, give you positive 1.33. Okay, so now this image, we just talked the second one, is the virtual, because Q is negative, upright, because this is positive, upright, well, because the first image is upside down, so second one also upside down at the same side. So okay, so now on the front of the second lens, front. Okay, of course that's y is negative, and the enlarge because it's bigger than 1. So now let's see overall the magnification. So the first one, make image smaller, okay, reduce to half. The second one, make a little bigger, 1.33. So now the total or overall magnification equals m1 times m2, negative 0.5 times 1.33, give you negative 0.67. So overall smaller, negative going to be the inverted, and the image going to be virtual. So now this optical system form a virtual image between the two lenses. Usually we call the first one objective lens, and second one is eyepieces, eyepiece lens. And this is a principle of, well, telescope. Now the rest part, please read by yourself. Okay, so mostly it's definition. And these examples when we have two lenses touch each other, one converging, one diverging together, what going to happen? Well, we're going to use this for our lab. So if you have time, we're going to discuss this later. Then the rest part, the last part is the section 7. So please read yourself. This is the end of chapter 23. Thank you.